Hello everyone. So in the last topic we have actually looked at confidence interval, yeah? And then you have also seen how we could actually take a sample from a population, all right, and infer confidence interval for the mean of the population itself. So do remember we always express confidence interval in the square bracket, and I still hope that you actually sort of remember this drawing earlier where we actually have the LCL. Remember what it is? The lower confidence interval and the upper confidence interval, all right? So this will actually be your left one and this will actually be your right one, all right? And then remember we actually said that I actually mentioned that confidence interval is actually going to be quite helpful for you in this topic here, in our new topic, and that would be actually significance testing, all right? So today we're going to look at significance testing, or in other words, people also call it the hypothesis testing. All right, let's look at an overview of what we're going to learn about this topic today. Okay, first, of course, we're going to just basically look at what's the concept, right? Simple concept actually. Once you have understood confidence interval, this will be really quick to really just grasp the concept. And then, of course, the type of error. You will learn that later we actually have type 1 error, type 2 error. So this is basically sort of like the introduction for significance testing, okay? And then, of course, the most important part would be the how-to, right? The how-to, basically how to solve the questions and all that. And of course, this how-to will be us dealing with the types, all right, of the test that we have. So the types actually are divided into two. We actually have one tilt test. We also have two tilt tests. All right. But actually, later when you look at it, you have actually been doing this all along. Probably you just never knew that it actually has a specific name called one tilt and two tilt. All right. So let's get started and look at the first part, which is the concept. Okay. So for the concept, right? So we have seen how it is for confidence interval. So for significant testing, or what we call as the hypothesis testing, okay? So what happens is that we usually make an assumption, all right? We make an assumption, or in other words, we make a hypothesis. And based on this assumption, we want to prove whether it is actually true or not. All right? Whether it's true or whether it's false. So, true or false? Oops. All right? So, that's basically what it is. And again, let's look at these in terms of example. Then it's easier for us to actually look at it later on. All right. So, suppose that we actually have a company. Let's call this company A. All right. And this company is a mobile phone manufacturer. And then this mobile phone manufacturer actually claims that its battery could last for 150 hours. All right. Before the next charge up. So, taking a random sample of taking a random sample of 40, okay, we're taking 40 samples here. It actually produces a mean of 147.4 hours. All right. So, assuming that the standard deviation for the population is 12, with a significance level of 0.05, do we, so let me just scroll this up a little bit. Do we assume or do we actually accept that this claim by company A is actually true or false? Alright, so this is a typical question of how it will look like in questions that require significance testing. So again, when we talk about this, so you see this company claims that the mobile phone actually has 150 hours before the next charge up. So it says now that they actually take random sample, that is 40, alright, and based on these 40 samples, they actually produce mean of 147.4. So see to that this mean of 147.4 is actually referring to your samples, yeah? That's your sample mean. And now what they give you is the standard deviation for the population of 12, significance level of 0.05, all right? And if you recall earlier, right? Remember in the last topic, we actually looked at alpha before? So again, alpha is also known as significance level. Sometimes you might see that, and this actually translates to 5%, isn't it? So sometimes if you work around it in a reverse way, sometimes they do not mention significance level. They might actually say it as 95% of confidence level. All right, so you see how both of how these can be expressed in two different ways and yet actually mean the same when it comes to you executing the question. All right, so let's start. Okay, so when we have question like this, how do we know, how do we go about it, right? So let me just show you what we actually usually do. All right, let's go to the how to. All right, how do we go about this? But you get the general idea, right? Significance testing. So basically, you just assume something. They assume that they actually have 150. And now they actually test out 40 samples and it's 147.4. And in other words, we might actually take another random sample of 40 and it could actually produce 155.5, for example, right? So now we are testing it, whether this is actually true or false of this assumption. So the how to, first step, all right? As you can remember, earlier I mentioned that for significance testing, we always make an assumption and therefore we actually need to set up what we call as the null hypothesis, all right? So null hypothesis here is actually my H0, all right? And alternative hypothesis. And we call this the H1. So this is the new term for you here, all right? So if you look at this example earlier, it says that, what is the assumption made here? Company A assumes that and claims that the mobile phone is actually 150 hours before the next charge up, right? So therefore, our H0 is that our mu is actually equal to my 150. You see how it goes, right? We usually go by the symbol mu here because this mu here and 150 refers to the population, right? It claims that all the phones in the company is actually of 150. And of course, after we have set, so this is my null hypothesis, yeah? My alternative hypothesis will then be H1. Alternative hypothesis speaks for itself, alright? It basically is just the opposite of your null hypothesis, alright? And in this case, how do we go about that? I'm just going to do it as not equal to 150, alright? So that's one. That's the most important thing. So secondly, second step, we need to know about the significance level. All right, very important. So know that this is significance level A. alpha, sorry. And in this case, they actually tell you it's 0.05. See to that sometimes they do not mention the alpha, they just mention significance level. Sometimes, again, like what I mentioned earlier, it's confidence level. So just know that confidence level will just be the remainder of what your alpha is. Yeah. So for example, if your confidence level is 95, then you're left with 5%, right? So 5% is actually your significance level, which is translated into 0.05. And after you have got this, this is where I mentioned to you earlier that your confidence interval, and of course, whatever topic that you learned from topic 2 earlier on your population distribution is important. So you want to solve it. And when you want to solve this, you want to look at the statistic that you want to use. All right. So basically, you want to look at your Z statistic. Most of the time, it's Z statistic because it refers to normal distribution. Yeah. So, and then let's get started. All right. So say that we remember, because it's mentioned that it's a significance level of 0.05. We know that it's actually 95% confidence interval. All right. And again, my normal distribution, I have my mu being claimed to be 150. All right. And what do you test earlier? Let's get started with this first. My alpha. My alpha is 0.05, which means it's 95% here. And therefore, again, looks similar to whatever that you have seen before, isn't it? So this is 2.5%. So you see the difference here? If you are just in a rush to just solve the question and without drawing this or visualizing it, I think I usually prefer to just draw it so that it gets a clearer view. But if you just visualize it in your mind and all that, don't just rush things through by just taking your alpha as 0.05, because now you can see that when you actually draw this out, yeah, when this is actually mu equals to 150 and you want to test whether the assumption is true or false, then you can see that it actually has been split into two, which is 2.5, which means the one that we want to work on later would be 2.5% or 0.025%. Yeah. And if you look at the previous question earlier, when we take a random sample, yeah, here, you see that random sample of 40 has its mean of 147.4. So I'm just going to like really quickly write it down here. I have my n random sample of 40, right? And then my mean is 147.4, isn't it? So this is, let's say it's somewhere around, okay, let's just keep this in mind first. All right, 147.4. And then what does it tell us? Also see to that standard deviation population is 12. Yeah, so which gives my sigma as 12. All right, so in this case here, again, we actually want to look at this part here and this part here. Okay, and the formula to go by it is mu plus minus z of alpha sigma over square root of n. All right, sometimes, just for you to know, they also call this as standard error. Okay, so again, we have come up with our null hypothesis. Okay, and then after that, secondly, the significance level in which we draw this out, 95% gives me 2.5%. And after that, what happens is that I will just write this down accordingly, according to the formula. Alright, so I already have this, and this is actually 150, isn't it? So this is actually 150 plus minus, of course, the minus for the lower part, and this one for the upper part. Alright, and my z of alpha, which is 0.025. So remember, we always represent this in terms of decimal. And we also have my standard deviation for my population, which is 12. And my n earlier is 40 because I take random sample of 40. Again, you see this, right? This basically means that with the probability of 0.025, what would be your z value? So again, this is similar to confidence interval. You will want to work your way in a reverse way, where you look at the probability and you look at which z value actually gives you probability of 0.025. Okay, in other words, normal table in reverse. And after calculating and all that, if you look at this in the table, it should give you about 1.96. This will give you about, well, rounded up to 1.9. Okay, and what this gives me then is 150 plus minus 3.72, which then will give me 146.28 and 153.72. All right, so what does these tell us? All right, so this basically tells us that 95% of the sample mean actually lies between this value. All right, in other words, I'm gonna just write it back down over here. So this value here actually will go by this part. It gives me 146.28 here, and it gives me here 153.72. All right, so now we want to look back. All right, now that we have reached this part, then we move on to whether we actually want to accept the assumption or not. We accept it if it's true, we reject it if it's not. All right, so, and then just now that was step 3, right? So step 4 is where you find your p-value. All right, so in this case, when you take a random sample of 40, it actually gives you the mean of 147.4. all right, so now you take this and you plug it inside this drawing that you have drawn earlier. All right, so 147.4 is clearly somewhere here, right? So this is actually my 147.4. What does this tell us then? All right, if I am just drawing it out again, I can see that this is a region, this is a region, and when tested, my 147.4 is not in the shaded region, right? So this shaded region is also what we call as rejection region. All right, so here comes the part where we decide. Okay, so the rule of thumb here is that if your H naught is in rejection region, then H naught, which is your null hypothesis, will be rejected. As simple as that. And of course, say if it is not in your rejection region, then we accept our null hypothesis, all right, which is H naught. So now, based on this itself, we can fairly say that 147.4 is not in the rejection region. So Therefore, the conclusion would be, since it's not in the rejection region, our null hypothesis is not in the rejection region, right? So this will be applicable, all right? So we actually accept the null hypothesis. And what is this null hypothesis? That it is of 150 hours. So which means we agree to the fact that this company claims that the mobile phone can actually last for 150 hours. All right. So just a quick recap for this part here, for the whole part here. First, you look at what the question wants and usually look out for the assumption. So the assumption is that it actually says it can charge up to 150 hours. Okay, so how do we prove that? They actually give you some data. They take 40 random samples with its mean, all the data necessary, and then they ask you, and of course the important one, the significance level, then they ask you whether you accept or you reject the assumption. So first step is to set your H0 and your H1. All right. So you see that since they claim it's 150, therefore your null hypothesis, your H0 will actually be set as 150 as well. And alternative hypothesis, just as what I mentioned before. And then after that, your significance level. Okay. And then after that, you move on to your statistics. And usually it's also of normal distribution. And by now, you must be very, very good at this already. I like to actually just draw it out so that it's easier to visualize. And then, because after I've drawn it out, I know that this is actually 2.5% each. All right. And then we go by the formula here. So this formula will be the important one for you. But again, you have seen this formula a lot of times. You can see that this is actually very much closely related to what you did for your confidence interval earlier, right? So after you have got that, then you can put in the values, because then you already know what is the cutoff region on this side and on this side. And then after that, you take what is being given, which is your 147.4, right? And then you check whether it is actually in your rejection region or not. Simple things, if you always go by H0, if it's in rejection region, then you just reject it. If it's not in rejection region, then it means we accept it. All right? So, based on this itself actually, right, I can actually even talk to you a little bit about what we mentioned earlier. Remember we talked about the error also, right? I told you that I was going to explain to you about the error. Okay, say that based on this example itself, right? In this example itself, I actually see that my H0 is accepted. All right. So when my H0, let me just write it down here. So I have my H0, I have my H1. All right. So when my H0 is true, just like what I have in the example here, and then I accept H0, of course, this is correct as it is, right? Let's say actually H0 is true, but somehow there's miscalculation or something, and it turned out that you actually reject H0. All right. And in fact, you actually claim that H1 is actually correct. So in that form, you reject H0 when it's supposed to be accepted. We call this the type 1 error. All right. Which means it's supposed to be H0 being true, but then someone assumes that and states that it's not true. So you have this error is known as type 1 error, and vice versa. So this is type 1 error. And then another one is called type 2 error. Type 2 error is basically for my H1. So H1 is true, which means my H0 is rejected. But on the other end, when H1 is true, but you actually reject H1. Then that would be called, or that will be known as type 2 error. Alright? So again, so this is just a little thing, a little bit of what you want to know about the error that we have. And then remember earlier also, if I just scroll all the way back up, we have looked at the concept, we have looked at the error. Yeah. From the concept, just now I actually show you one example. From the example there, and then you can see that what constitutes or what differentiates type 1 and type 2 error. Alright. And then the how to, do you notice? I showed you one example, and then I mentioned that it actually is of two types, which is one tail and two tail, right? Can you guess whether this particular question is a one tail test or two tail test? I'm just going to give you a few seconds to think about it. And as usual, you have got this right. All right. So we have one tail test, and we also have two tail tests. All right. So how do we see the difference and all that? The example earlier is of two tail tests, because why? You actually have this part here and you have this part here. That's what they mentioned for two tail tests. All right. That's what constitutes two tail tests. For one tail test, of course, it can be of this region to the left hand side. And in this case, usually the assumption is of something that is less than, yeah? Or alternatively, could also be on the right hand side. Let's go into the right side. We play with the sign of bigger than. And as you can predict already, what about the sign for this one, right? Remember in the earlier example, we actually claimed that the battery life is 150 hours. So actually this 150 hours here is where we actually look at equal or not equal to. Alright, so that's basically sort of like a way for you to differentiate between the two. That's why whenever you have questions that claims an exact amount, so you want to draw this out and you want to make sure that you know this is two tilt test, because then from there your alpha will then have to be divided by 2. Alright, so that's one thing for you to know. So now that you have looked at the example on this earlier, let's try another example on one tilt test. Alright, so we'll do that in the other video.